In this video, I'm just going to show you a quick way to solve a limiting reactants problem. So here's the question. If 2.5 moles of copper and 5.5 moles of silver nitrate are available to react, what is the limiting reactant? So here, I'm going to start off with my 2.5 moles of copper, and I'm going to convert it directly to moles of silver nitrate. So in my T-table, start off with 2.5 moles of copper. I'm going to use my mole ratio. So in front of the copper, I have a 1, and in front of the silver nitrate, I have a 2. So it's a 2-to-1 ratio. My 1 mole of copper goes on the bottom, so my units cancel out, and my 2 moles of silver nitrate go on top. Now, I have 2.5 times 2, and that equals 5 moles of silver nitrate. So, what exactly does this tell us? This tells us that for 2.5 moles of copper, I'm going to need at least 5 moles of silver nitrate to react with all my copper. So, the question you have to ask yourself is, how much silver nitrate do I actually have? Well, I see right here, I have 5.5 moles of silver nitrate, and I know 5.5 is well over what I need to react with all my moles of copper, which is just 5 moles. So therefore, I know I have enough silver nitrate, so therefore my copper is my limiting reactant. So 2.5 moles of copper is a limiting reactant for this problem. In this video, I'm going to show you a limiting reactants problem. So here's the question. If 2.5 moles of copper and 5.5 moles of silver nitrate are available to react, how many grams of silver will be produced? So the first question you ask yourself is, what is the problem asking for? The problem is asking for how many grams of silver. So we know we need to convert to grams of silver. Now, what makes this a limiting reactants problem is the fact that we're starting with 2 different quantities of reactant. So we start with 2.5 moles of copper, and we start with 5.5 moles of silver nitrate. So in this case, we're going to need 2 separate T-tables. In my first T-table, I'm going to start off with 2.5 moles of copper, and I'm going to convert it to grams of silver. So 2.5 moles of copper, I'm going to have to use my mole ratio between copper and silver to convert to moles of silver. So here I have 1 mole of copper, I have 2 moles of silver, so it's a 1 mole to 2 mole ratio. Notice I put my moles on copper on bottom, so my units cancel out. My next step is to convert to grams of silver using the molar mass of silver. The molar mass of silver is 107.87 grams per mole. I'm going to put my moles on bottom, so I have 1 mole of silver for every 107.87 grams. Again, I put my moles on bottom so that it cancels out with moles of silver, which I was previously at. So, my next T-table, I'm going to go from 5.5 moles of silver nitrate to grams of silver. So I'm going to start off with my 5.5 moles of AgNO3. My first step is to use my mole ratio, which is a 2 to 2 ratio. So 2 moles of silver nitrate on the bottom and 2 moles of silver on top. My last step, once again, is to convert to grams of silver using the molar mass of silver. So it's the same as above, 107.87 grams of Ag for every 1 mole of Ag. All all that's left to do now is to calculate our answer. So I'm going to reduce the size of this so I can make my calculation. Start off with 2.5 times 2. So 2.5 times 2 times 107.87, and I get 540 grams of silver. My next calculation is 5.5 times 2 divided by 2 times 107.87, and I get 590 grams of silver. Because I get a smaller number with my moles of copper, that will be my answer as far as how many grams of silver can be produced. That is because my copper will limit the amount of silver that will be produced. And that is how you solve this problem.